Hello, everyone. Welcome to the live stream. Let me get some things set up. Go ahead and make sure that's sharing. Okay. Okay, great. We're going to get into some pre-algebra and algebra 1 topics today. I'm Beth from my tutoring bee, and just a few live stream rules and community guidelines that I've got up here. Also, some ways to support me. If that's something that you're interested in or able to do, that really helps me out a lot. Thanks so much for joining me. I'm actually going to wait just a little bit, see if anybody else joins. We're going to be talking about, what are we going to be talking about today? I always set these up like a week in advance, and so sometimes I forget what I'm doing when we come back to this. Right, we are continuing with our transformations. Today we're working on reflections and dilations for our pre-algebra section. I'm going to be spending about, I'm going to try 15, 20 minutes for each of these different sections. So we've got reflections, dilations, and then for algebra 1, we're talking about multiplying binomials and then factoring trinomials. So kind of like what we did last week, where we multiplied things together and then learned how to separate it back apart and factor it out. That's what we're doing here with the binomials and trinomials. So let's go back up here. Oops, sorry, move far there. All right, so let's go ahead and start talking about our reflections. So we've got a reflection. Actually, let me back up before I just dive into this first problem. All of these worksheets are from software in the pre-algebra section, and it's pretty easy to find. You just go to the section about transformations, and you'll see a link there for reflections. They're all free worksheets. If you're interested in printing these out, following along with me, then that is what I'm going to be using. So now a reflection. Think of turning a page in a book or seeing your reflection in a mirror. So these are all going to be rigid transformations, meaning that the shapes are going to stay congruent to each other. So the size isn't going to change, but the orientation will change. So since we are going to be reflecting this first problem across the x-axis, anything that is, and here's our x-axis, I'll just highlight it here. Anything that is below the x-axis will now appear, is going to appear up above, and anything above will now appear below. So let's take a look at this triangle. We've got triangle LGQ. And so one way that we can do it is just by counting how many units away from the line that we are reflecting? So I'm going to show you with this first problem, and I'll show you a different way in some of the other problems, or maybe with the same problem. So point Q is 1 unit away, 1 unit lower than the x-axis. Sorry, let me make this a little bit thinner. It's 1 unit below the x-axis, so then that means Q prime is going to be 1 unit above the x-axis. So that's where Q prime is going to be located. And then we can do the same thing with G. G is 1, 2, 3, 4 units up above the x-axis. So then that means that G prime is going to be 4 below. So down here, G prime, all right? L is 2 units above the x-axis. So we're going to go 2 units below the x-axis, and that's where L prime is going to go. I'm going to clean this up a little bit, get rid of sort of my little counting jumps here. There we go. And then we're going to connect all of these points with our straight line. So now we have our reflected triangle. All right. And so then let's take a look at our reflection across y equals 3. So these are a little unique. A lot of times you'll just be asked to reflect across the y-axis or the x-axis. But whenever you're given something like this where it says y equals, that is just a line that we can graph. So let's graph that line first. And graph it. I'll do it in red. So y equals 3. We talked about graphing before, a little bit before. So we're going to be on the y-axis, and we're going to have an intersection of y equals 3. 1, 2, 3. 3 here. And then we're going to have a line that goes right across. So it's a horizontal line. Okay, there we go. Sorry, just checking on my light just to make sure that we're all good there. So now this is the line that we are reflecting over. So what we can do is just, again, do the counting method. L is 2 units below this line. So we're going to graph L 2 units above this line. It happens to be right on the same spot that U is on. And so then that means that U is going to be 2 units below the line since it's currently 2 units above the line. So that means that we can do U prime here. They're just going to switch spots. And then X is 2 units above the line. So then X prime is going to be 2 units below the line. And then we're going to, again, connect those points. Great. So, I forgot to show you about how to do this algebraically. I'll show you with this first problem right here. Whenever your reflection is across the x-axis, then that means that your y values are going to change signs, which might seem counterintuitive, might seem like it's backwards since it's the x-axis and then the y portion of the coordinates is changing. But let's think about it. Let's look at Q. The original Q is at 1, 2, 3, 4, 4, -1, right? Like that's its original spot right here. If we're reflecting across the x-axis, the x portion of that coordinate point is not going to change. It's going to be, it's still in line with 4 on the x-axis. But what is changing is the y position. So instead of being underneath the y-axis, so the negative y's, now it's going to be above. So whenever we have a reflection across the x-axis, let me write Q prime here. Because now it's 4 +1 for Q prime. So a reflection across the x-axis, we start with xy, and that's going to change to x -y. So whatever our y portion is, we're just going to switch the sign. If this said y-axis, reflect across the y-axis, then it's going to be opposite. Our xy is going to change to -x +y. So again, the y value wouldn't change, the x would. So instead of being positive, it would become negative, or negative would become positive. All right, let's go on to write a rule to describe each transformation. So the transformation is already done for us. We have reflections. We just have to figure out where they are reflecting it. What line are they reflecting it over? I do have a full video on my channel about this where I also go over how to reflect across lines like x equals y or y equals x. So you can check that out too. I have all of that in the description for you. Okay, so let's take a look at this one. Visually looking at this between these two triangles, I can tell that it's a vertical line that we have reflected over. And it looks like we have a line. We always want to pick the line that is right in the middle. This one's pretty, oh, got a little crooked there. This one's pretty easy to see because one, these triangles are pretty close to each other. But take a look at our I and I prime. They're each just 1 unit away from this line. So the first thing is identify where the line is. Now the second thing is, what is this line? How do we write this line? Because it's definitely not either the y or the x axis. So this looks like it's going through at -2 on the x axis. So our equation for this line is x equals -2. So just like in this last problem that we did, y equals 3, that's going to intersect with the y axis right there at +3, and it's going to be a horizontal line. When we have an x equals something, it's going to be a vertical line, and it's going to go through the x-axis at that spot. Okay, and then let's take a look at this one. So these are a little bit further apart from each other than you can imagine, but I can see one thing that we can do is we can just pick one of the points. So G prime and G, those are the closest points to each other. So I'm just going to count 1, 2, 3, 4. They're 4 units away from each other. So half of 4 is 2. And then we've got 1, 2, or if we're starting here, 1, 2. So it looks like this line is our line that they're reflecting over. So that is the y-axis. Now, this is also, we could also say x equals 0, but y-axis is usually the way that we write these when we're doing reflections. Okay, let's go on to our dilations. Let me see here. Trying to keep an eye on the ads so that they don't pop up on you too much, like right in the middle of a problem. I'm still working on trying to figure out how to work with the ads, either manually entering them or just trying to keep an eye on them. But sometimes that's hard. So I apologize if you've gotten any so far. Let me know if you have. Actually, that would be really helpful information for me to know, because I don't know. I actually don't know if the ads just go over what I'm doing or if it like restarts where it left off, like, and you just have to catch up a little bit. Um, so yeah. All right. So this, I actually current software do not have any dilations on the free websites. So I found this at this website, Idia.app, and you can just go to this part, Idia.app, and then just look for dilations. Just do like a search for dilations, or you can type all of this in to get these. But I really like this website. I've been using it a lot more lately, and you can really like pick specific skills, very similar to CUDA software. Okay, anyways, let's talk about dilations. So dilations are non-rigid transformations. So they are going to change size. Whenever our scale factor, this is scale factor is the number that we're using to multiply. Whenever our scale factor is greater than 1, then it is your image is going to get larger. Whenever your scale factor is between 0 and 1, so a fraction or a decimal, a fraction or a decimal that is less than 1 but higher than 0, so we don't want it to be negative, then that is going to shrink your image and make it smaller. So we can see in these first couple of problems, they give us the scale factor. So in both of these, I picked one with a number higher than 1 and one with a fraction, so that we could see the contrast of those two. We're just going to first find the coordinates of each of our points and then multiply both the x and y by that scale factor. So it's pretty simple. It maybe can feel a little tedious, but it's a pretty simple process. I'm gonna label my little quadrilateral right here since they didn't give us points, just so that I can list them out over here and it doesn't get confusing. So A, it looks like, is at 1, 1. B is at 4, 1. C is at 1, 2, 3, -4. And D is at -2, -2. And I left space in here so that I can write in my new image coordinates. A prime. All right, so again, we're just going to multiply both x and y by whatever the scale factor is. In this case, it's 3. So 1 times 3 is 3, and 1 times 3 is 3. So our A prime is going to be at 1, 2, 3, 1, 2, 3, right here. A prime. All right, and then for B prime, again, we're just going to multiply each by 3. So 4 times 3 is 12. 1 times 3 is 3. So B is going to go to 12, 3. 1, 2, 3, right here. That might seem pretty extreme compared to A. We'll go over that in a little bit, but it has to do with the center of dilation. Does it say? Yes. Dilation about the origin. So we'll talk about that in a little bit. Let's go ahead and finish finding all of our coordinates here. So C, we're going to multiply again, 3, and then -12. So we've got 1, 2, 3, and then down here at -12. So again, C prime is kind of far away, especially compared to how close A and A prime are. And then D prime is going to be -6, -6. So -6, -6, D prime. Great. We're going to connect all those points. So because our center of dilation is the origin, then that means that the further away from the origin our original point was, then that's going to be a lot more extreme because we have higher numbers the further away that we go from our origin. So when we multiply that, it's going to be a lot more extreme of a jump. Notice also that because DA, the line DA, is going through the origin, our new line of A prime D prime is also going through the origin. We'll see on this next problem, because none of the points nor the lines are going through the origin. It'll all get closer into the origin, but nothing will actually be passing through the origin. So let's actually do that. Let's jump into this problem. So we've got create the image of the triangle under a dilation about the origin with a scale factor of 1/4. Move the blue points to the new coordinates. Oh, okay. I think, yeah, because this was digital, you could like move around, but we're just doing it by hand. All right. So again, I'm going to, I don't want to use X, Y, Z because I don't want it to get confusing with the X's and Y's in our coordinate points. L, M, N. We'll call them LMN. So point L is at, looks like -4, -4. Point M is at 0, 4. And N is at 4, 0. Okay, great. All right, so again, we're just going to multiply. Whenever you have a fraction that has a 1 in the numerator, another way to think of it is that you can just divide by the denominator. that's what I'm going to kind of be thinking when I'm calculating these is these numbers divided by 4. So L prime, -4 divided by 4 give us -1. M prime, 0 divided by 4 is still just 0. And then 4 divided by 4 is 1. And then N prime, 4 divided by 4 is 1, and then 0. Let's go ahead and graph those. So L prime is -1. So as you can see, a lot closer to the origin. M prime is 0, 1. M prime. And then N prime is right here at 1, 0. So much smaller triangle and closer to the origin, but still not going through the origin. All right. Last problem that we have for this one, and then we're going to take just a quick little break and then come back for the Algebra 1 problems. In this one, the transformation has already happened, and so we're going to figure out what the scale factor is. So one of the ways that we can do that, let's see, let me read this. The polygons triangle DEF and triangle D prime E prime F prime are depicted on the graph below. The triangle D prime E prime F prime, that's kind of hard to say, is obtained by dilating triangle DEF about the origin. What is the scale factor of this dilation? Okay, so you can see that the blue triangle is the new image because they've got the primes for the vertices there. And the black triangle. So we know that the scale factor has got to be greater than 1 because this triangle is clearly bigger than our original triangle here. So one way, I feel like this is a little too small. Hold on, let me just fix this, kind of zoom in a little bit here. There we go. So let's just take a look at one of the points. We really don't have to do all 3 points. So F is 1, 2, 1, 2, 3, 4. So it looks like 2, 4. And then F prime is these lines. I hope you can see this okay. 1, 2, 3. So that's 8. And then it looks like 16. I guess I had to like really zoom out on this one in order to be able to capture all of that triangle because this does go up somewhat high. So then what do we see here? There's a couple of different ways that we can look at this. What is it that we had to either multiply from the first point to the second to get to the second point? Or another way that we can think of this is new over original. We take just one of these numbers, the new number is 8, the new x value of f prime is 8, and the original was 2, and then let's reduce that down. 8 divided by 2 is 4. Well, 2 times 4 would give us 8. So that means that our scale factor is 8. Sorry, 4. There we go. Okay, quick break, and then let's get into some algebra with multiplying those binomials. Okay, we are back. We're using software again on this one. It's in the Algebra 1 section. Pretty easy to find multiplying binomials in sections dealing with polynomials. In fact, I can probably look that up and show you. So here's the Algebra 1 section. If you want to go to different sections, you just click on this free worksheets and you've got the drop down here. Hold on, I don't you can see this. Sorry, there we go. Okay, so click on this where it says free worksheets. You can find the drop down here. So this is where I get my pre-algebra work. We're already on the Algebra 1 page right here. And then here in the polynomials, we've got multiplying polynomials, multiple special case polynomials, I think is where I got this from. Yeah, it does have a few other types, but I grabbed some of these that are just the 2 binomials that are multiplied together. Okay. Great. All right, so then let's get into now. When students are first learning this, a lot of times they're taught the FOIL method, FOIL. That stands for first, outside, inside, last, meaning that when we are multiplying this, the first thing you would do is multiply the 2 first terms in each set of parentheses, and then you would multiply the outside terms in each set of parentheses, and then the inside terms, and then the last terms from each set of parentheses. Now, this is a great method. I have no problem with this method. And in fact, I call it this method a lot because that's a lot of my students know it by that name. However, what we're really doing is the distribution property. So if we talk about the distributive property more, then that helps us a lot when we are trying to multiply, let's say, a binomial times a trinomial. Because when we get into a trinomial, then we don't have that first, outside, inside, last setup. So some students kind of get confused with that. So really what we're doing is we're taking this first term and we're distributing it and multiplying it times both of these terms in the second set. And then we're going to do the same thing with this last term and multiply it times both of these terms in the second set. So either way, we're going to wind up with the same answer. So let's go ahead and start with 4n times 2n. So whenever we're multiplying with variables, the coefficients can just get multiplied together. 4 times 2 is 8. Excuse me. And then n times n gives us n squared. And then we're going to distribute to 6. So 4n times 6, it's a positive 24. And that n just stays there with that. Now we're going to multiply positive 1 times 2n. So we get another positive 2n. And now 1 times 6, which is positive 6. Now we do wind up with like terms in the middle here. Typically speaking, the 2 middle terms will be like terms, but not every time. So we just want to identify any like terms and go ahead and combine those. So 8n squared, we've got our plus 6. And then right here in the middle, we're just going to add these together, positive 26. And that's it. We have multiplied those 2 binomials. If you have any questions while we're going through these, please feel free to ask. Happy to answer any questions that you have as we go. All right. Let's go ahead with this one. So 8p, we're going to go ahead and distribute to 6p. So 8 times 6 is 48. P squared is p times p. And then we've got 8p times 2, which is 16p. Then we're going to multiply our negative 2. Remember that whenever you have a subtraction sign in front of a number, here that gets carried with that term, and we treat it as if it's negative. So negative 2 times 6p gives us minus 12p. And then negative 2 times positive 2 gives us negative 4. And again, we've got those 2 like terms in the middle there. So 48p squared. 16p minus 12p is positive 4p minus 4. And that is that one multiplied. And then I've got one more for us, just for good measure. 3m times 8m is 4m. 3m times 7 is 21m. Negative 1 times 8m is -8m. And then negative 1 times 7 is negative 7. And then we're going to combine those like terms in the middle just to simplify. Oops, I forgot my m squared. Sorry, that's supposed to be an m squared right there. So we've got 24m squared, and then 21 minus 8 would give us 13, so plus 13m minus 7. And that's it. All right, now on this next page, we're going to do this in reverse. So we're going to start off with one of these trinomials, and it's going to end up looking like this with those 2 sets of parentheses and 2 binomials. So let's take a look at that. Okay. All right. So we've got these 2, not these 2, these 3 different trinomials set up here, and we want to split it up into 2 binomials. I'm just going to go ahead and set up my parentheses down here on the bottom. Now, there's a lot of different methods. Some people use the box method. I've heard of X games where you use an X to kind of help you determine what numbers multiply to our last term and add to our middle term. But and I'll show you both of those methods. They're all great methods. Just I like to show different methods and then pick which one you like, pick which one works best for you. But we're always going to start with this first term, b squared. And we want to know, what can we multiply to get b squared? Well, for b squared, it's just going to be b and b. So those are going to be our first 2 terms in each set of parentheses. Now we're going to jump over to the plus 7. And then this is where, like, I'll show you X games. So a lot of people call these X games, where you put a big X next to the problem. And you want to know what adds to 7, what multiplies to 7, and what adds to the middle term, which in this case is positive 8. So what 2 numbers? Well, with 7, that's pretty easy. I mean, there's only 2 numbers that multiply to 7. That's going to be 1 and 7. So if we add 1 and 7, that's going to give us 7. If we multiply 1 and 7, oh my gosh, why do I keep mixing that up? I'm so sorry. It's been a long day. If we multiply 1 and 7, it's going to give us 7 up at the top here. And if we add these 2 numbers, it's going to give us 8. See, that's what I would have done something like that in a session. And my students would be like looking at me like I have 5 heads. And then I would give them the classic, I was just trying to make sure you were paying attention and that you knew how to do it. So anyways, so these 2 numbers are going to be our other terms inside these set of parentheses. And because everything is positive, this 7 is positive, this 8 is positive, and we're going to have pluses in there. And I always like to save the signs for the last step, just so that we're not worrying too much about the signs until we get to the point where we actually need them. But that is it. That is how we factor those trinomials. Now, all of these trinomials that we're working on today I have a equals 1 up here. That just means that there's no coefficient, meaning that this coefficient is an understood 1. So that's what this means, and that's the more basic way, more basic level, I should say, of doing these types of problems. Once we get into coefficients higher than 1 for this leading term, it gets that's just the next level of it. It's not necessarily like super hard. It's just the next level of it. Okay, let's take a look at this one. So we've got m squared, m and m. M squared is going to be split up into m and m. So that's where we're going to start with that first term. Now we're going to take a look at 90 and 1, right? This is an understood 1 here for this term that we've got here in the middle. Now notice that I didn't put a negative here. We will eventually put the negative, but basically what I want to do with this is figure out, again, which numbers multiply to give us 90 and add to give us 1. Now, the negative 90 is going to be part of it. We do need to consider that. When we get a negative product, that means that one of our numbers has to be negative and one of our numbers has to be positive in order to make this a negative 90. Another way, I actually really like the T-chart method a lot better than the X games method. So with the T-chart method, what we're going to do is list out all the different factors of 90. So what I do is I always start with 1 and the number itself, so 1 and 90. And then can 2 go into it? Yes, that's 45. Can 3 go into it? Yes, that's 30. Can 4 go into it? No, not evenly. Can 5 go into it? Yes, that would be 19. Can 6 go into it? Yes, it can. We just keep going down until we get to um, our until we get all of our factors. So let's see, 6 can go in one time, 3 left over. Okay, so that's 5, so 50. Right. And then can 7 go into it? No. 8, no. Can 9? Yes, 9 and 10. Now that and then the next number would be 10, but we already have 10 here on this side of the list. So that's how we know that we're done with the T chart. Now, we talked about how one number has to be positive and one number has to be negative. So that means maybe we're switching our thinking a little bit to subtraction. Which of these pairs of numbers could we subtract to get 1? Well, that's going to be 9 and 10. So now let's think about how do we make that a positive one? 10 would have to be positive, the 9 would have to be negative. So then that helps us to know what to fill here into our set of binomials. So that is that one factored. All right, one last one down here. We've got n squared minus 10n plus 9. Let's go ahead and do that. N squared, we're going to break up into n and n. And then for 9, I'm going to go ahead and do t here. Now notice 9 is positive and 10 is negative. So let's think about what that means. We've got 1 and 9. Let's see, 2 does not go in. 3. 3 is the last one. 3 and 3. So which of these adds to 10? Well, that has to be 1 and 9. But 1 plus 9 would not equal negative 10. However, negative 1, negative 9 would add to negative 10. And they would also multiply, if we want to do the x, they would also multiply to positive 9. So negative 1, negative, if we multiply these, they're going to give us positive 9 still. If we add these, they're going to give us a negative 10. So we've got negative 1 and negative 9 for our two factors for that one. Okay. That is all that I have for you for tonight. Thanks so much for joining me. I do really appreciate it. If you're watching this on a replay, don't forget to like and subscribe. Leave me a comment. Let me know. Do you like these live streams? Are these more appealing than just my regular pre-recorded videos that I've been posting on YouTube for 12 years now? Let me know what you think about these live streams. It sort of gives you, I think, a little bit more of a glimpse into how I tutor. I know we don't have a lot of the back and forth that I would with a normal student, but I think still kind of gives it an idea of my teaching style. And I'd love to hear from you. So thanks so much for watching, and I'll see you next week.